So we have a pretty boring live implementation of console I/O, which we can now provide. And this pattern is going to show up more and more in this project, where we have a deferred representation of some effect, and then we have some implementation of that effect that actually performs that effect on the system state. The point of adding this console I/O is to introduce a mechanism by which I can test the interactive run mode of this. Right now, this program only has an info command implemented, which will print out the parsed information from a list of ROMs, and I actually want to run them. In this case, I kind of want to run them as if they were running in a debugger. I don't want to say debugger because I'm not actually looking for bugs. It just is kind of a command-oriented run mode. Right now, there's nothing defined there, so we'll start developing this definition and continuing with using question mark, question mark, question mark to expand in the bits that I don't know. So what are we talking about here? Well, here is the input to the command as called, where it just gets a path that's a string and it does an effect. Well, first, I don't want to define run in terms of a file. I want to define run in terms of data from a file. So we'll go ahead and invoke our same operation as above to implement that. And I'm not going to write that subsequent definition yet, because what we're expecting is a conflict here. There's only one run definition, and this is not a string. So we'll introduce a new run definition that actually takes the data and does the same thing. And now we should see that this compiles, but now we have this hole to fill in. Okay. So for now, we're just, we have some system that is an NES. I don't know what that is. And we have some UI, which is we'll call it a CLI. Why not? It is a command line interface. And we know that's going to be defined on this same console I/O thing. That was the whole point of introducing console I/O. And then actually just want to dispatch to that run. And we want to say it takes a system for input. We still don't really know what this system is going to be, but this is going to get us to a few different holes. One, dead code following this concept, and it says that sys was inferred to be nothing, which is as we'd expect, and type not found CLI, which is also as we expect because we haven't introduced it yet. So I'm just going to introduce a package system here, and I'm going to introduce a file called NES, and that's going to represent the NES system. I don't know what this is going to be yet, but that's actually as far as I need to write code for that class, and we will initialize it like so. So then we have now introduced our NES class, and now we'll introduce the CLI. But you know what? I just thought of something. We have our package object here, and there is no I/O that I can really use right now for Scala native, but what I can do is start annotating things as I/O. These aren't actually going to be anything, but they're at least going to be type annotations I can apply. So we will go ahead and call this I/O. So at least now I can find usages of I/O and find it fairly easily. Even though we don't have one yet, I presume at some point ZIO will be available for Scala native, and I'll just be able to swap that in for a lot of this code. The syntax is going to be different because I'm not going to be using for comprehensions versus just sequencing, but it's going to be good enough that I'll be able to chase things down easily. So anyways, back to our subject at hand. We have our UI, which is going to be a command line interface. It depends on console I/O, our effects of doing console operations, and it is running against a given system that is initialized with a data source. For the implementation of this interface, I'm going to follow a pattern that I use for services in general, and that is to make it a event-driven system such that there are three classifications of events. First case are queries, which examine the running system without making changes to the state of the system. The other are commands. Commands would explicitly change the state of the system. Then there are requests to exit. And these I just refer to as events. A bit overloaded with all of these being referred to as events, but that's all right. So right off, just adding the structure, we find, of course, that we don't have read event defined, query, command, or the value exit. And I'm going to go ahead and say this is part of our user interface domain language. And I'm going to introduce an event structure under UI. And we have our parent type event, but we've also mentioned two other types, commands and queries. We're going to go ahead and introduce all of those as sealed traits. Then we've mentioned one additional one called exit. Right off the bat, we've cut down on those two type errors, and now we have another no value found. Okay, not really sure what read event is going to be yet, but it is in fact going to be IO that produces an event. And we'll just start there. That's sufficient to satisfy the compiler, and now we're left with 4 unknowns. The exit case, easy. We just wanted to return, exit out of this run. The other two cases are necessary to dig into a bit deeper. When discussing a query, I said it is something that only examines the current state of the system. And I'm imagining a command executed at the CLI mapping to one of these query events. And from the user perspective, this query event producing a value, and this value being displayed to the user. We can put that in prose as something like query is applied to system state to result of query is displayed, and then 3 repeat run loop. It's fairly easy to put in prose, but really we can just start writing that code directly. What do I mean is that the query is applied to the system. So we're going to say the query is a function from the system to some result. And then we have some function, display query result, that takes that result. No change is expected to the system. And as that this is an immutable structure that we're working with, that means that we run the run loop with the same value as provided. Okay, so that's the structure we would expect from executing a query. And again, right off the bat, the compiler is going to tell us that we don't have 2 values. That is fine. One is a method is expected of query that takes the system and produces a query result. So then this should result in a missing type. Yep. But now this apply method is located. We have one more method here that's missing. So we will just say display query result. And result is going to be of type query result. And this is going to be an IO of unit. And we will fill that in later. And now we've reduced our 2 errors down to 2 instances of the same error, a missing type query result. Query result, really I would expect any query result to just be something that we could display at this point. I'm not really interested in adding some structure to that. I'm going to say a query result is any value that can be constructed that just provides console pretty printing operations. Okay. Now we have a query result is just anything that is pretty printable to the console. Query is a function that is applied to the system that produces a query result. And we know that system is not changed by this event, as the same value in is the value provided to the next iteration of the loop. Speaking of event loop, this is clearly something we want to be tail recursive. So we will instruct the compiler to both verify that it is tail recursive and perform the tail recursive optimization if it is. And of course we had to make it final for that to be doable. And so far it is tail recursive. Okay, so now we've broken down our program into a new unknown, which is the implementation of display query result, and two existing ones, which is the implementation of command and implementation of read event. We're going to leave these two for later, and for now we're going to go back to command. And in command, it's explicitly something that should change the result of the system. And I'm going to say it should both change the result in the system and have some result to display. We're going to follow the same pattern as query for the most part, except for now the run is performed next with the new state of the system, which means likewise need to produce a case class and a abstract definition for apply. And we will do much the same. Now command result from this usage here, I'm saying that run is performed with a system provided in that result. So command produces a result when applied to a system, and as part of that result is a new system. So very similar to a query result, that means there are two parts to this. One is a sys, which is the new state of the system, and the other one is the pretty print stuff that we want to see to view the result of the command. And likewise for display query result, we now have display command result. I'm not even sure I will end up implementing these two functions, but in terms of constructing program iteratively, I'm going to introduce them just as different functions to make it clear the direction I'm going. It might be, for instance, deleted and just a single function that operates on this common pp attribute used, for instance. I'm going to stop there. Now we have the beginnings of a CLI event loop that reflects the two general classes of interactions I want to do: queries to examine the state of the system and commands to manipulate the state of the system. And we'll continue with implementing read event and these command and query operations as a start next time.